All right, y'all. So this is Miss Murphy. Sorry I'm not here again today. I'm actually in the building, but I have been drafted to get the ACT. So if you have any questions after this, please feel free to see me either during my playing during fourth period, or you can come see me after school or shoot me an email. But apologies again for yesterday. I was sick, so I had to stay at home. But we are going to go ahead and get started with the new lesson, at least the more simple side of it. So, today, if you haven't already, make sure you grab that journal from the front of the room and glue that into your journal. So, today we're talking about the zeros of quadratic functions, which another name for that is solving quadratic functions. So, as always, we have our I can statement, which is I can find the zeros of a quadratic function or excuse me, quadratic equation through graphing, factoring, and taking a square root. So today we're only going to focus on how to find the zeros through graphing, which should be very similar to when we discussed the different key features of a quadratic last week. Now, the factoring and taking a square root part, we're not going to learn until I'm with you guys again tomorrow. So hold off on that part. We're only focusing on the graphing aspect. So before we start, let's actually review what zeros are. So you've already heard this name before, but zeros are just another name for the x-intercepts of a quadratic equation. So again, we've already learned how to take the x-intercepts from a graph. Remember, the x-intercepts are where your graph crossed the x-axis. They are also known as the roots or solutions of a quadratic function. So that's why we say that this is like solving a quadratic equation, because the x-intercepts are actually our solution. So think back to linear equations. When we solve them, we will get x equals a number. Similar in this situation, but we'll get x equals up to two numbers. Now, there are several ways to find the zeros of a quadratic equation, and we're going to do it through graphing. If I could actually spell correctly, y'all. Through graphing, factoring, and taking a square root. Now, the graphic below is just to kind of show you what's going on. So there's a couple of different types of solutions that you can have. So remember, you can have up to two with x-intercepts. So you can have two solutions or two roots, which is where it crosses the x-axis twice. You can have one solution or one root, and that's where it crosses once. And that also means that typically, if it crosses the x-axis once, that also means that your x-intercept is its vertex as well. Remember, that's the highest or lowest point of the graph. And then no solutions means that it doesn't cross the x-axis at all. So if the x-axis is here, the two graphs placed on there are obviously not crossing the x-axis at all. So if it doesn't cross the x-axis, it doesn't mean that there's no solution. It just means that it does not have a real solution. So this is not really no solution, it's no real solution. And then in math 2, you're going to talk about what that means. And you're actually going to find the non-real solution. But just for this class, we only care about if you can identify that there's no real solution, meaning it's not a real number. So whenever you have no solution, so to speak, I expect you to write no real solution. All right. So if we go to the second flap, graphing quadratic equations, typically for these, we're using technology or by hand. And this is a method to find zeros. So by technology, what I mean is Desmos or your graphing calculator, but Desmos is a lot easier. I don't really expect you to do it by hand, but it's still a good practice to do for the sheer fact that you may have to do it on the EOC. So get into the habit of learning how to do that. Now, a zero on a graph are the x values of the x-intercept or x-intercepts. So if you need, so all we really care about for the zeros are the x values. We don't really want the points. So unlike when I asked you guys to list the x-intercepts, I asked you to list them as a point. Here, I only want x equals the set of something, whether it's the two numbers or the one number or whatever. So your steps for finding the zeros by graphing is first you want to graph the equation in Desmos. So you either graph it in Desmos, or if you're doing by hand, you're going to create a table of values and graph the points. And by creating a table of values, I mean pick a couple of x and y value, pick a couple of x values, plug it into the function, get the y. Then we determine the x-intercepts. And again, it's located on the x-axis. And then we want the x values of the points, and we're going to write them as x equals the set of whatever numbers. Now, remember, a quadratic graph can either have 0, 1, or 2 x-intercepts, and we have to state all the x-intercepts as your zeros. So it's not a matter of picking one or the other. If there are two, you state both. So let's look at some examples. So for this one, we're actually going to be graphing the equations. You can either do this by hand, or you can do this by creating a table in Desmos. But let me show you how you would do it by hand for example 1. So I'm going to show you how to get 1 point by hand. So if I were to do this by hand, I would create a simple table value, so x, y. And I'm just going to pick some random x values. So let's say I have -1, 0, 1, 2, and 3. Now, I'm going to find it by hand for when x is 0. So what I'm going to do is I'm going to take 0 and I'm going to plug it in for x in our function. So if I'm going to write it off to the side, I would have -0 squared plus 2 times 0 plus 3. And then I'm going to evaluate that. So 0 squared is 0, 2 times 0 is 0, plus 3. So my y value is 3. So this would be the point 0, 3. So if you were asked to find it by hand, that's how you would go about it. So if I did it as -1, I would have -1 squared plus 2 times -1 plus 3. -1 squared is 1 times a negative is -1. 2 times -1 is -2 plus 3. So that'll be -3 plus 3, which is 0. So this would be -1, 0. And then if I did 1, I have -1 all squared plus 2 times 1 plus 3. So 1 squared is 1 times a negative is -1 plus 2 times 1 is 2 plus 3. So 2 plus 3 is 5 minus 1 is 4. This would be 1, 4. So right here, if I do it for 2, oops. I have negative 2 squared plus 2 times 2 plus 3. 2 squared is 4 times a negative is negative 4 plus 2 times 2 is 4 plus 3. Negative 4 plus 4 is 0 plus 3 is 3. So right here. And then finally 3, 3. So that would be negative 3 all squared plus 2 times 3 plus 3. So 3 squared is 9. So negative 9 plus 6 plus 3. 6 plus 3 is 9. Minus 9 is 0. So right here. So my graph looks like this. Now, if I find my x-intercepts, they would be right here. This is the point negative 1, 0. This is the point 3, 0. So I only care about the x values. So my answer is x is equal to the set of negative 1 and 3. And when we use set notation, it's just saying that these are the different values of x that would work for this function if we solved it. All right. Now that was by hand, but if you wanted to do it in Desmos, I already have Desmos pulled up. So in Desmos, I already have the first one graphed. And as you can see, it does give us those 2 zeros. Now, if you were creating a table so you could graph it, you can also do the gear key, hit the table, it generates that same table, and then you can get some more points. So that's another way you could have done that. Now, the next example, we're actually just going to simply graph in Desmos. So we're just going to graph this entire function in Desmos and get the zeros. So I already have it graphed in Desmos, which is right here. Make sure that you type it in exactly. Now, this one appears to only have 1 0 because the vertex is also the x-intercept. So at this point, we have the point negative 3, 0. And again, we only care about the x value, so this would be x is equal to negative 3. Now, if there's only one number, you can state it as just x equals that number. You don't have to actually put the set notation. It's really for if you have 2 answers. And then the final answer, or final question, I should say, again, we're going to graph it in Desmos, which I already have graphed here. Now, as you can see, it does not cross the x-axis at all. So even if I take the x-axis or the y-axis away, you can clearly see that that graph is not anywhere near the x-axis. So there is no real solution here. So it's not no solution, because technically there is a solution, which you will find out in Math 2, but it's just not a real solution. It's what we call a complex or imaginary solution. So we're just going to state this as no real solution. So remember, you got to put the word real in there. It's not just no solution, it's no real solution. Now, another thing to remember is, just so you guys don't get confused, do note that's only the x-intercepts that are solutions. The y-intercept is not a solution, so please do not get confused with that. All right, so it's the x-intercepts only that contain our solutions. All right, guys, so you should have enough to do the first couple of sections of your 8.3 Delta Math. Only do the parts that say to solve by graphing. If it says to do it by factoring or taking a square root, do not do it yet. All right. And once you finish that, you're free to work on any other Delta Math that you have not finished. All right, that's all, and I will hopefully see you guys tomorrow.